if you have been curious to know or to know more about the field of electrical engineering, particularly what is happening there and what are the new things, right from the simple level or the fundamental level up to the advanced level, then this is the right channel for you. The name of my channel is JK Solutions. Please don't forget to subscribe to my channel by pressing the word subscribe in red color at the right hand side of the video, especially at the lower part of it. And don't also forget to tap the notification bell so that you can be receiving all the videos that will be posted hereafter. Today I will be doing a video on how to wire a lighting point, which is a very fundamental topic, and it's also common because many people must have been wondering, how does electricity work, or the electrical system, how does it work? We want to know today by making use of this simple topic. Hereafter, we'll be dealing with design and installation, even covering the areas of high-rise buildings and a project covering wide areas. So before we go further, there are certain things that ought to be known as far as the electrical system is concerned. For instance, in this case, a standard electrical system or a standard electrical arrangement has three components or three parts. In this case, for the purpose of this wiring a lighting point, we'll be using 13 amp switch socket in combination with 13 amp plug, whose fuse inside it has been replaced with 10 amp fuse in order to be compatible with the size of the cable, which is 1.5 mm PVC copper cable that we are using for this for the purpose of this illustration or this video. Now, this is, as I said, this is 13 amp switch socket. We have the X terminal, the neutral terminal, the live terminal. This is what one will see when one opens. I'm going to show where the 13 amp socket as well as the plug and the switch as well. This is 10 amp 250 volt switch. So that is what we are going to use here. So let me start with the 13 amp switch socket. This switch, this is the switch here. Alright, and when the way it is, just the way I'm holding it, the connection is made. There are three terminals, the live terminal and the neutral terminal as well as the X terminal. So we are going to use this one. This, for the purpose of this illustration or this video, this switch socket here is, is expected to have been pre-wired. Alright, this one is already in existence. It has been pre-wired. Now, just the way it is here, because it is very easy to carry out a simple installation like this, or simple wiring exercise like this, making use of 13 amp plug, because 13 amp socket rather, because it is easily accessible. You can easily find 13 amp switch socket around or anywhere in the installation system, because the ideal supply source is the distribution board, the miniature circuit breaker distribution board. But it may not be easy in some cases to have direct or easy access to distribution board, because it will disturb other loads connected to distribution board. So the easiest way or the simplest way is to look for a 13 amp switch socket around, in combination with a 13 amp plug, and then the wiring cable. The wiring cables are 3 of them, single core, 1.5 mm square PVC copper cable. The here is pointing to the cross-sectional area of the conductor. The conductor is inside is wrapped with insulator, and the type of insulator used in this case is polyphenol chloride insulator, and the conductor itself inside the cable is copper. So it is the cross-sectional area of the conductor that is, for instance, if you have this conductor here, actually it has some cross-sectional area. That is the one you calculate, and that is what is 1.5 mm square. All right, so we move forward. Now this is about the socket. All right, then the plug. This is a 13 amp plug. When it is opened, what you will see is this. Before it is open, there are 3 pins. This is the arc pin, the live pin, and the neutral pin. When it's going inside like this, when you open it, this is what you see. You see these 3 terminals, 1, 2, 3. This is the earth terminal, the biggest. Is the biggest terminal of the 3. Then you have the fuse. You have the fuse. This is 13 amp fuse, which I said is replaced with a 10 amp fuse in order to be able to protect this 1.5 mm copper cable. A 13 amp fuse will not sufficiently protect the cable, because the current carrying capability of 1.5 mm copper cable is very close to 13 amps. So I think the best fuse size to use in this situation is 10 amp fuse, so that the fuse element will melt before the cable will get burnt. So what we are saying is that the relation is that, or the connecting statement is that the current carrying capability of the connecting cable should be greater than the rating of the fuse. So a 1.5 mm copper cable will has a rating, a current rating of slightly more than 10 amp. So we make use of a fuse that is less than the current that 1.5 mm can carry. So that is the way it is. So when after coupling this thing back, so and we couple it back, and when we are ready to switch on the circuit, we take the plug, this plug, and plug it into the 13 amp switch socket. So we finish with that. The other control device that we have here, in this case, this is a control device. This is a 3-gang 10 amp switch. So these are the 3 gangs, 1, 2, 3. Although in this situation we are only making use of only one switch. So, and it's rated 250 volts. It means it can withstand a voltage of 250, and it can also control, you can switch on and off a circuit where we have 10 amp current flowing. So this is it. This switch is this one. The terminals are here to make connection. One. In this situation where we need just only one, we only make connection to this and this. Alright. So now we come to the circuit itself. As I said, this pre-wired this pre-wired 13 amp socket has 230 volts, alternating current at 50 Hz. This is the frequency of the sine wave, the voltage sine wave, as well as the current sine wave also. So from here, this socket and the plug constitute or make up what we call the source. Then from here, from the fuse, this is the fuse link, the fuse here, and we insert the switch into the live conductor of the installation. So the same we have the for the X also, which is color green and yellow, or green only in some cases, is X conductor. Then we have the neutral conductor as well. The live conductor is at 230 volts relative to that of the neutral conductor. The neutral conductor is always, if there's no fault, the neutral conductor is always at 0 potential. That is 0 volts. The potential of the earth is also 0 under a normal or a fault-free condition. Then there is no fault at all. So in most cases, the voltage of on this neutral conductor and the earth conductor, they are usually same. So you can use, you have three wire system for lighting, provided that you have earth terminal on the electrical load. In this case, the electrical load in this case is the LED, light emitting diode, 15 watts, and it can operate on 230 volts without any problem. It's a bulb. We can have energy saving bulb as well, and some other types of bulb that we, or in some cases we have electrical fittings or light fittings. Really, instead of having ordinary bulb, we have a housing that houses the bulb itself, and that is what we call fitting. In a situation where we have housing, and we have the bulb inside. That's a light fitting. So in this case, we have bulb with the lamp holder. This is the lamp holder. Lamp holder. This one. Okay. Lamp holder. Because it's holding the lamp. Now, in some cases, we have 3 terminals on it, but some lamp holders may just have only 2 terminals. In that case, you cannot use earth wire or earth conductor. That one will not be there. But in this situation, we have a lamp holder that has 3 terminals: live, neutral, and earth. So these 2, they are the source. And then we have the control device here for switching on and off, and then as well as the wiring cable, the red conductor, the black which is the neutral conductor, and the earth conductor, each of them being 1.5 mm square in size. Alright, so this is how this one is. Before I go further, still on this switch socket, Tenon switch socket, conventionally or by standard, when you have the socket like this, the right hand side pin, or this hole here, the hole here is expected to be the live terminal, while the terminal to the left hand side is the neutral terminal. This upper terminal is expected to be the earth terminal. Alright, and when you come to the plug, when you hold the plug like this, the pin that is here, this pin, will be the live pin, denoted by L here. The one at the upper part, which is the biggest, is the earth pin, which is this one, and the other one is the neutral pin. So, and this is the load. Anything that makes use of electricity or that consumes electrical power is an electrical load. Okay, so from here we move on. In a situation where you have access to a distribution board, then the source of power supply in that situation will be the distribution board through the circuit breaker. And the kind of distribution board that we usually use is called the miniature MCB distribution board. MCB distribution board. Distribution board. Okay. So this MCB, as I said before, is miniature circuit breaker. We have other types of circuit breakers, such as a molded case circuit breaker, which we are going to talk about in future. MCCB, we call that one. That one is MCCB. So molded case circuit breaker. So we are going to use for the purpose of this experiment or this video, we are going to use MCB distribution board in a situation where you don't want to use 13 amp switch socket in combination with a 13 amp plug as source. So we can, as I said, it is possible to take supply directly from distribution board, even though in some cases it's difficult to access it. That's why I'm using this arrangement for the purpose, which is very easy. Alright, we continue with the use of distribution board as source of voltage. In this situation, instead of having a socket as source of voltage, here we are having this is a distribution board. All right. This is a distribution board. I'm representing distribution board with this, and what do you see inside the distribution board is the copper bar, represented in red color, and it is that copper bar which is the live part of the distribution board, the miniature circuit breaker distribution board, which is the source of voltage in this situation. So that is the alternative device to using sockets as the source of power supply or voltage supply. So inside the distribution, you see the copper bar, which is the one for the live, and then another bar, the neutral bar, which is here, and the earth bar. So what really changes is replacement of the combination of plug and the socket with a distribution board, a miniature circuit breaker distribution board. All right. So, and everything remains the same switch as it is. And as I said, this is the load. So again, we are having three sections or three parts. The source, that is the source of voltage in the installation. We are not talking about installation on a very wide area, just like I mentioned before. For instance, a university campus. The source of, we can have so many sources of voltage there. For instance, the transformer can be the primary source of voltage, and inside each building, or by the side of the building, we can have feeder pillar, and inside the building we can have we will have distribution board as well. So I'm talking of a small installation in this instance, and so we are having MCB distribution board as a possible place, or as a kind of device or appliance from where voltage can be tapped. So, and here it is, that is the load. We have the source, we have the connecting this cable, 1, 2, 3. We are connecting cables, as well as the control device, which is the switch, and the load. Anything, as I said before, anything that consumes electrical power is an electrical load. So, and the examples are electric bulb, we can have kettle, we can have air conditioner, so some and so on like that. Anything, any appliance that makes use of electricity to perform its function is an electrical load. Alright, then we move on and calculate the current in this circuit. We will simplify the diagram and calculate the current flowing in the circuit. Yeah, as I was saying, if the need to calculate the current flow in the circuit is required, if there's a need for that, we calculate the current flow in this circuit. Now, it is the same light emitting diode bulb, which is rated 15 watts, 230 volts AC. Okay, this is the symbol. I'm using this symbol to represent the bulb. When you have a circle with a cross inside, it depicts or it symbolizes a kind of bulb that is installed to the ceiling. So this is the same bulb. We are using 15 watt 230 volts LED bulb. Now, and this I is the current. The current flowing in the circuit is I. So this is the current. I is equal to current in ampere. So this current will be in ampere. Okay. In ampere. Okay. Now, how do we calculate the current flowing? The first thing is that, all right, you have this, you can have this flowing, the return part. This is the live and the neutral. We have neglected the earth conductor here, or the earth cable, since it is not really taking part in the real current flowing. The current is flowing through the live conductor and the neutral conductor. The purpose of the earth cable, we will be discussing that one in future. So here we have the power P, the real power P is equal to 15 watts. But looking at this LED bulb, it could be written there, and in some cases, and it may not be written. All right. Given that the power factor is 0.6, then apparent power S in the volt ampere VA will be equal to P over power factor. Okay, which is equal to 15 divided by 0.6, and that is equal to 25 VA. Okay, that is 25 VA. And when you have that, the current I is equal to VA, that is S in VA divided by 230 volts. So, and that is equal to 25 divided by 230. Okay, and that is equal to 0.1 ampere. Okay, so current I, this current I, this is equal to 0.1 ampere, and that is the current flowing in the circuit. So looking at it very well, the power of the bulb, that is the active power, is 15 watts, and this is it. And given that the power factor of the bulb itself is 0.6, because if you look at the reason, an LED bulb is never a heating load. It has a power factor component because it has something that is similar to choke. It's not a choke, but it has some electronic component inside it, which gives rise to the power factor. In some cases, it's usually 0.6. It could be more or slightly less, depending on manufacturer of the bulb. So in this situation, the power factor given that it is 6, the apparent power S, which is measured in the VA, is equal to active power P divided by the power factor, that's 15 over, and that is 25 VA. So we can now calculate I, the current flow in the circuit, as being equal to S over 230 volts. That is 25 over 20 over 230, and it's approximately 0.1 ampere. And that is how it is. Thanks for watching. And once again, please don't forget to subscribe to my channel so that you can be receiving all the videos that will be posted hereafter. That is the presentation, and that is the magnitude of the current as indicated here. Please don't forget to subscribe to my channel by pressing the word subscribe in red color at the right hand side of the video, especially at the lower part of it. And don't also forget to tap the notification bell so that you can be receiving all the videos that will be posted hereafter. Thank you very much. Thanks for viewing.